Hi everyone, welcome to HOTH 11. My name is Sam and I'm going to be giving a short presentation on servers that will help you build your own server for your application. So if you want to follow along, here's the link to these slides. Also in the bottom left-hand corner of every slide, I'm going to put the link to our README, and there you'll find more information on specific things that you might need to install to help you follow along. Oh, let me move my camera. All right, so today we're going to be covering what is a server. We're going to be talking about HTTP APIs, and then finally we're going to finish up with a demonstration of how to build your own server using Flask. So what is a server? Well, the first thing that comes to my mind is a Minecraft server. And this isn't too far from what we're going to be talking about, because like a Minecraft server, servers will have addresses, and you can also do cool things with them. And no, yeah, it's not a tennis serve or volleyball serve, but it is similar in that a server does send stuff. So what is a server? A server is a program that will return some response after a client request. That's a very vague definition, and technically pretty much any application runs on quote-unquote a server, but we're going to be talking specifically about servers that you'll be writing yourself to manage a database that I'll explain in a second. All right. So how do we understand servers? One way is through the restaurant analogy. So a server is kind of like a waiter at a restaurant. You ask the waiter for a specific order, and then the waiter will bring back what you ordered, just like this. Now, in reality, I think it's a little bit closer to the picture on the right, where you see there's a lot of different options to choose from, and the waiter doesn't necessarily just like bring back one specific thing, but a lot of things go on to put all these different things together. So one way to conceptualize this in a diagram is right here. So you, the customer, are also going to be called the client in the case of a software server, and you will send your request to the server, aka the API, which I'll define soon, aka the waiter. The waiter will go to the kitchen where the chef, or in our case, the database, will prepare all the ingredients that are necessary, and things are going to happen. They're going to be put together, and voila, you'll get a burger or whatever you ordered back, hopefully. So why did I say hopefully? Well, sometimes you don't actually get what you asked for, and that could be because you asked for something that they don't have, or maybe you didn't ask in the right way. So make sure when you're ordering at a restaurant, right, you don't just start chatting with the waiter about whatever, but you want to follow the menu, you want to follow a specific syntax and a protocol. And so what is that? Well, that would be called the server's API. So every server has an API, also known as an application programming interface, which defines the specific types of requests and responses that you can make and receive from the server. So previously, you may have watched the video on web APIs, and web APIs are just servers that somebody else already wrote for you, but we will be making our own server API. So what exactly do we want to do? Well, there are 4 key operations that normally we find are going to be useful to do with respect to a database. And those operations are create, read, update, and delete, also known as CRUD. we're going to be using HTTP in order to implement these. There are other ways that CRUD gets implemented, so you can use GraphQL. CRUD is a very abstract concept, so you can even like apply it to other things as well, but we'll just be focusing on HTTP today. So we're going to be making, in particular, a REST HTTP API. All right? So what is a REST API? And aren't all HTTP APIs REST APIs? Well, the answer is not quite. So the REST framework stands for Representational State Transfer. And what that means is that every time that you send a request to the server, it's going to return to you a representation of the state of the database that you have, basically, and you're using that server to manage. And if you want to learn more about the specifics of REST APIs, I'll also go into more detail as we implement them. Please check out this article just to explain how to make sure that when you make your server APIs, they actually follow the REST format. All right, so there's two things that can happen when we communicate, right? You can either make a request to the server, or the server can respond to your request. Now, there's a specific format for all requests and responses when we're talking with REST HTTP servers, all right? And that's known as the Hypertext Transfer Protocol. Inside of a request or response, there's always going to be three parts. There's the start line. In a request, it's known as the request line. In a response, it's called the response line. I know, very, very aptly named. Then there's going to be the headers. And most of the time, you don't need to worry very much about the headers. This is just metadata. Sometimes it might contain information about authentication and other things like that. Depending on what type of use cases you have, you might need to modify these, but usually you'll be good. And then after a blank line separating the headers from the third part, we have our final part, which is the body. And in any HTTP request or response, the only thing that is guaranteed to be there is the start line. So headers and body are optional, but in some cases, you'll definitely want those. And we'll dive into the details of what those cases are. All right, so looking a little bit more closely at the requests, you'll notice that in the request line, we have three parts. So the first, we see right here, it says post. Post is an example of a type of request that you can make to a server. And there are many different types of HTTP requests, but the four main ones that are pretty much all you ever need to know are post, put, delete, and get. All right. And then the next thing after this post request, here we just have a slash, but actually this is a URI. So that could be like slash customers slash whatever. It could be a full URL. This is basically the place or the endpoint that you are making your request to, and it specifies a location. All right, and then the final thing is just the version of HTTP we're using. That doesn't really matter very much. And then in the case of a response, we see the HTTP version is the first thing. After that, we have an HTTP status code. And then after the status code, we get a very short message that summarizes what the response is trying to say. Cool. So let's dive into more details about HTTP requests. So let's say maybe you're making an app where you have like this garden that you have a lot of plants in, for example. So what might you want to do with your garden, which in the back end is going to be stored in a database? Well, you might want to plant a new plant, in which case we're going to post um, to this endpoint called /plants. All right, and this is going to make a new plant in our garden. What if we want to delete a plant? Well, then we're going to delete. We're going to use the delete request at the endpoint /plants/ and then here I put ID in braces. This is just a placeholder where you would typically specify the ID of the specific plant that you're trying to delete because every plant here should have its own ID, and in this way you are specifying which plant you're trying to delete inside of the endpoint. All right, and then what if you want to get a specific plant's information? Maybe how long the plant has been in your garden, or what type of plant it is. Then maybe we could call get on /plant/ID. Or if you want to get a list of all the plants in your garden, maybe you would do that through a get request at /plants, just by itself with no ID added on top, which intuitively you should understand to mean getting all the plants information. And then finally, we have put. Put is used whenever we want to update an existing item in our database. So if we want to update one of our plants, maybe we renamed our plant from, I don't know, strawberry 1 to strawberry 2. Well, we need to change this plant in our database without actually adding a new plant or deleting a plant, because we're just modifying the same plant. Its other information is going to stay the same, right? So we're going to make a put request to that specific plant using /plant/ and then the ID of that plant. Cool. And this sort of framework of post, delete, get, and put really translates to pretty much any sort of database you're going to be using to store data with in your application. All right, so we made a request to our database, and we wanted to get information on plant with ID number 102, but it turns out that we don't have that many plants. What's going to happen? Well, our server is going to be smart about it, and it's going to send us a response with a 404 error, which means that thing is not available in your database. And whenever you get a 400s error, that means that the request that you made is not valid or it's broken in some way, which usually will be explained inside of the message of the response. But you can also look up the specific numbers and what they mean on the MDN docs, which I'll link in the README. But usually you want to get anything in the 200s, because if you get a response with a 200 status code, that means that whatever you try to do successfully was accomplished. If you get a 500, that means that the server itself had an issue, and that is an error, but you'll have to go debug that in your server code instead of on your client side. Cool. So I mentioned making like a get request, for example, to get information on a specific plant. But where does that information go? Because in the response line, all you're going to get is like the HTTP version, your status code, and a short message explaining the status code. Well, the actual information is going to go into the body, and it's going to be in the format of a JSON, aka JavaScript object notation. Now, you can actually send a lot of other different formats as well, like HTML, XML, etc. But it's usually the case, and it's most preferred and recommended to use JavaScript object notation, especially when we're working with JavaScript-based front ends like React. And JavaScript object notation is very easy to learn, because if you know what a Python dictionary is, well, a JSON object is literally the same thing as a Python dictionary. As you can see, we have key value pairs. The value can just be a value, or it can be another JSON object nested inside, or it can be a list. The only thing here that is really strict is that the keys have to be strings. So yeah, we're not just going to send information in any format. We want it nicely packaged in our JSON object. Okay, so I've been alluding to the fact that you're going to be wanting to write a REST HTTP API server in order to manage a database. But why? Well, my tip is actually don't if you can avoid it. For example, if the only thing your application is doing is logging someone in, just use Firebase because they already made a really great integration that does that automatically for you. But chances are your application is going to store very specific application-specific information per user that's going to be used in order to do whatever your application does. For example, in the cases of our garden application, we're going to be storing specific plants for a specific user. And in that case, we probably want to write our own server API to manage our database. And here's a database. Whenever you have one of these, you run the risk of having to write your own REST API. But don't worry, it'll be fun. All right, so how do you write your own REST API? Well, there are many different frameworks to write server APIs. These are called backend or server-side frameworks. You can use whichever one you find to be most comfortable. Today, I'm going to be making a short example using Flask, just because I find it to be very lightweight and simple to set up and easy to learn. But if you want to keep everything in JavaScript, go ahead and use Express. And if you know how to use Django, then go ahead and use that. And there's plenty of others as well. Yeah, we're going to be using Flask. Now, one of the reasons why I love Flask, or at least one of the reasons why I thought I loved Flask, was that it looked like it was shaped like a jalapeno. But unfortunately, I found out it's actually the shape of a flask and not a jalapeno, so rip. Oh well. Okay, anyways, now let's actually go ahead and write our server API. All right, so I've just briefly made a folder here, and all my front end stuff I put into this folder called client. You can call it front end. We're going to be using that later just to demonstrate how you can integrate your back end with it, but I'm not going to be spending too much time focused on that part. Instead, let's go ahead and make our backend, aka our server API. So I'm going to be calling this backend to store all our backend stuff. Here you would probably put your database and also your server API. In our case, I'm going to go ahead and create our Flask API. I'm going to be calling it app.py. Some people like to call it api.py, run.py. Really, it doesn't matter. Just pick whatever you want. Cool. And then this is in Python. So one of the great things about Python is that there are a billion libraries, and you can basically do anything you want if you have the right library installed. But that also kind of means that you want to have a virtual environment to store all that stuff, unless you want to be downloading a bunch of stuff into your main environment. So just to demonstrate that, I'm going to go ahead over here. I'm going to go ahead and cd into our backend. And it looks like I already have a virtual environment on, but I'm going to go ahead and deactivate that. Oh, okay. Well, let's go ahead and create a new virtual environment. This is how you do it. Python-m vnv, and then just the name of whatever your environment is. I'm just going to call this flask demo. All right, and I'll just create an environment wherever you are currently CD'd into. Cool, great, took a little bit. And now let's just go ahead and activate our environment. So how you do that is you just type your environment name /bin/activate. Great. So now our environment is activated. And this way we can install the libraries in here and it's not going to affect our broader environment. Awesome. So let's go ahead and get started. So we're going to go do our imports. So from Flask, import Flask. We'll also use request. And then I'm going to be using the Flask RESTful library, which is a extension on top of Flask that ensures that the API that you write is going to be RESTful. It also simplifies, in my opinion, the API writing process, but it might look a little bit different from what you're used to. So just be prepared. All right, so these are all the imports we're going to need. Oops, not that one. Let me just explain all of this really quick. Oh. Okay, autocomplete is a little bit annoying sometimes. There we go. So Flask is just going to give us the basic Flask implementation. Request is going to allow us to access the request for our HTTP request that we're going to make to our API. And then, like I said, Flask RESTful is a library that ensures that your API is going to be following the REST framework. And then cores, it's just a good practice to always use cores when you're building your backend, just so that you'll see later on when your front end is trying to access your server. If you don't have cores enabled, sometimes you can have like authentication issues or just permissions issues, and so that's just something you need to watch out for. All right, so this is how we initiate our Flask API. And then we'll just ensure that we wrap our application in cores. Cool. And since this is a Python script, we always want to have this line inside of our Python script. If name equals main, then specify what we're going to do. So in this case, we're going to run our app, which makes sense. And then the debug is equal to true because we are currently in a developer phase. All right, so normally, before I get started implementing our API, normally when you implement your server API, you're going to have your database, which is probably going to be either a SQL database or some sort of NoSQL database like MongoDB. And you're going to want to connect that to your Flask API. And depending on what type of database you have, it's going to look different. So here today, going with the same plants example that we had before, I'm just going to make this fake data table just directly hard-coded into our server API. You would not do this. Ooh, okay, autocomplete. Wow, gave me this really nice data table. Let's go ahead and add one more plant. Nice. So what this fake table is it's structured in a way that's going to be very similar to how your tables inside of, for example, a SQL database might be structured. You're going to have your primary key, which has to be unique for every single item in the table. And then you're going to have other columns that are going to have values associated with them. So in our case, we currently have 4 plants in our table. They have names, they have type, and they have age. you are probably going to have multiple tables in your database, and like I said, your database is probably going to be in a separate location. Whatever type of database you have, whether it's SQL or NoSQL, just search up how you integrate with Flask, and there's for sure going to be a library like SQL Alchemy, for example, that you can just import into your Python script and just integrate it directly like that. All right, but assuming you have successfully integrated your actual database, I'm just going to use this like fake data table right here. And then how are we going to make our server API? Well, we got to think about what do we want to do with our data. Okay, and let me just explain one thing about REST APIs really quick. So when you make a REST API, all your endpoints, aka the URIs that you're sending HTTP requests to, should be nouns and not verbs. So we want to think about our data in terms of resources. So what types of resources do we have? Well, we remember that the 4 types of HTTP requests, the 4 main ones, we can make our get, post, delete, and put. What if I want to get information about this plant, this specific plant? All right, well, in that case, we would go ahead and define that resource. So our resource is a single plant, and then we're going to go ahead and define a get request. All right, and because it's a single plant, like in our previous example, we're going to be accessing, or we're going to be specifying which plant we want based on its ID. So we're going to be passing the ID as well. And then we're going to return the information about that plant based on the ID that we got. All right, so that looks pretty good. Cool. But what if this plant actually is not in our database? Then we can't index a dictionary based on an index that is not in the dictionary, right? So it's a good practice and a good habit just to go ahead and define a function to make sure that you're not getting something that isn't in your database. And one great thing about Flask RESTful is that we have this function that you can import from it called abort, which will automatically generate a 404 error in that case. And so that's really something we want to go ahead and do. So let's just use this default code right here. It looks pretty good. Basically what it's saying, this function, it'll take a plant ID if the ID is not inside of the keys of this dictionary, or in your case it would be inside of that table. It's going to call our abort function with 404 error, and then the message, the plant, whatever ID we tried to get information about doesn't exist. So let's go ahead and put this function right here. And what this will do is if we try to call this get request on this plant, if it wasn't in our database, it'll automatically abort, and so we don't need to worry about returning some invalid information, because it will instead return this message. Cool. Well, okay, that's great. We can get information about one specific plant, but what if now I got tired of this cactus and I want to delete this cactus? Well, let's go ahead and define our delete. So it's going to be structured in very much the same way. It's also, we can't delete something if it's not in our database, so we will call this method to ensure that we don't delete it if it's not there, then we can call delete, and if we have successfully deleted something, we're going to return a 204 message. Remember, everything in the 200s means success. Over here, we didn't return a number because by default, it's automatically going to return 200. And in the case of our GET request, that is what you want. So I didn't write it, but you could, if you wanted to just be explicit, write it right over here. How the return statements work, by the way, is first we have the body. This is going to go into the body of our HTTP response. Then we're going to have our status code. And then over here, if you have headers, you can go ahead and define those. We are not going to be working with those today, but in your case, you may find that you will want to do that. And so just a heads up. All right, and then finally, what if I actually change my mind? I don't want to delete this cactus, and let's say I haven't deleted it yet. Instead, I just want to modify it a little bit and change it from cactus to like aloe vera, for example. Well, whenever we're modifying an item, we use a put request. All right? But wait, here's something interesting. So when we send a put request asking to modify this resource, we want to now specify what we're changing. So if we're changing the name from cactus to aloe vera, where are we going to put that in our HTTP request? We're going to put it in the body of our HTTP request. In what format? In a JSON format. And how are we going to get the information out of that JSON? So there's a reason why I imported this thing called request parse from Flask RESTful, because it is another very useful tool that will allow you to parse JSONs that are sent in from HTTP requests in order to get the information and do the operations that you need. So over here, let's go ahead and use this right here and define for ourselves a parser. So recparse has this cool object called request parser, and then very similar to argparse in Python, all you have to do is add the different types of things that you're going to be parsing from the JSON. Specifically, you're going to add the keys that you would expect to find in the JSON that you get, and then that'll allow you to parse the JSON based on those keys. So right here in our table, we have name, type, and age as our keys. So I'm going to go ahead and add those to our parser. And then age is a float, so we'll go ahead and add type equals float. Cool, so now we have a parser. This is going to allow us to get the information from the body of our HTTP request in order to actually do stuff with it. So now our put request makes a little bit more sense. So first off, we're going to call parse args, and then that's going to go ahead and give us a structured or destructured format of our JSON. Cool. Now, what if our plant ID is not in plants? In that case, we can go ahead and create a new entry in our table. And if it is in plants, then we'll go ahead and define it as we wanted. So we're going to have our plant. We're going to, args is now a dictionary whose keys are the arguments that we added to our parser. We can access this stuff. This is whatever got read in from the body of the HTTP put request. And then we're going to go ahead and assign that to our table. All right. And then we're going to return a common convention for a put request is just to return the information that got put into the database. And then our status code for a successful put request, or any request that creates something is going to be 201. Cool. So in this way, we have now defined how we can get information about a specific plant, how we can delete a specific plant, and how we can put our, when you see put, you should think update. We can update information about a specific plant. But all of these require basically prior knowledge about what the plants are. What if we don't even know any of their IDs? What if we just want to go ahead and view all the plants in our database? Well, that is a different type of resource, right? Here, we're talking about one plant, but now we're going to be talking about all of them. So we're going to be creating a new class. It's inheriting from resource, which we imported from Flask RESTful. And let's go ahead, get a list of all the plants through our get request. All right, so now if we want to get a list of all the plants, we have a get request that does that. And it'll give us all of this information right here. The ID numbers, we won't return with it just because normally when you have a database, those ID numbers are kind of encapsulated within the database. They're generated by the database. They're probably going to be hashes, not just integers like right over here. And then if we want to add a new plant to our database, here, really this function, although the way we made it, it could actually add a new plant to the database. That's really optional. We didn't have to put this part right over here. Instead, we could have put a abort if does not exist plant ID error over here. It really depends on how you want to make your put request. So try to make sure that your put requests generally are used for updates and not for adding new information. In the case of adding a new plant, we would want to make a post request. And usually we do not know the ID because that is made by the database. Instead, we'll just post to a generic endpoint, and then the database will go ahead and create everything, or the server will go ahead and create it in the database, which will create the ID for it. All right, so this was kind of auto-completed in VS Code. But as you can see, first we're going to parse args. This will automatically take the body of our request and parse it into this dictionary based on the args. Cool. Then we need to make another unique ID for our table. In our case, we're just going to take the maximum ID, add 1 to it. It shouldn't overflow, guys. We're not going to have that many plants. All right, and then we're going to go ahead and create this new entry in our table with whatever we decided to post to our database. And in the case of a successful post, we're also going to respond with a 201 status code. Same thing over here. This would be 200. It's just omitted because it's by default. Cool. And then this is the message, just like a put request. So put and post requests are very similar, but don't get confused. In a post request, it's also a good practice just to respond with a message of what you put into the database, just to make sure everything was interpreted correctly. All right. Now, so far, if you have actually made an API in Flask before and you did not use Flask RESTful, which is recommended to make a REST API, then you may be wondering, where are our endpoints or our routes? Well, we're going to do that right now. So we define this API over here, but we haven't actually done anything with it yet. Now we're going to actually add endpoints to our API. So API.add resource. And how many resources do we have? We have plant list. So we're going to go ahead and add plant as one of our resources. And then what shall we define this endpoint as? This looks good. This is the URI where we can do all these requests on. Cool. And then over here, this is a generic URI where we don't know the ID, so it'll just be plants. Awesome. So now we have two endpoints that we can call these specific requests on. If you do any other types of HTTP requests that you did not define here, that is going to throw an error. So when you make your server, you're probably going to write a lot more requests, but for the purposes of our demo, we're just going to do this. Awesome. So here's an example REST API written using Flask. How are we going to actually get this server up and running? Well, we made our virtual environment. If you haven't already, just make sure you have all the things installed. So pip3 install flask underscore restful flask underscore cores. I'm pretty sure I already have all those things installed, so I'm not going to do it again. But in your case, that would just be what you need to do. And then after that, just go ahead and do Python app.py. Because of this thing that we put right here, it's going to run our server. Oops, what is this? No, don't want that. All right, let's run this. Oh, okay. Looks like when I created this new virtual environment, it did not have Flask. So let's go ahead and install these things. Pip install Flask. Okay, and then let's go ahead and install the other things as well. Cool. Now I believe everything should be working as we want it to. Let's go ahead and launch our server. Great, our server is running, as you can see in the terminal. So how do we actually verify that our server works? Before we start writing stuff in React, a much simpler way to just test your server is to use Postman. So I have Postman extension installed for VS Code. The link, or there should be a description in a GitHub how you can do that. Postman is just this really great tool in order to test endpoints of servers. So let's go ahead and do Postman, create a new HTTP request, and I'll open this new tab over here where we can start making HTTP requests and receiving responses from our server. Cool. All right, so it's nicely formatted, so you don't have to type everything in a very typewriter fashion. But as you can see, this is still our request line. Our body is over here. Our headers are over here. These are other things, authorization you might use if you have specific endpoints that you only want specific users to be able to access, for example. But for now, we just need these. Okay, so where did our server say it was running? It said it was running at this URL. So I'm going to put this URL over here. And then what are the endpoint URIs that we had? We had plants, and we had plants placeholder for an integer, which stands for the plant ID. So let's just go ahead and see what plants are currently available. So let's make a GET request to the plants endpoint. All right, this hopefully will return a JSON representing the plants in our database, and voila, it does. So we have ginkgo, kelp, cactus, and a fern. Wow, lovely. And then, as you can see, like I said, 200 is the default response. I could write it explicitly as well. It will make no difference. And because this is in debug mode, it'll automatically refresh. It does nothing. Cool. So that's great. We have the plants in the database. Let's test out adding a plant. Okay, let's post a new plant. So our body is going to be in a JSON format. You can click raw, change this to JSON. Remember, JSON is just like a Python dictionary. And what do we need to know about a new plant? We need its name, type, and age. So let's see. What type of plants do we want to add to our garden? I'm going to add a strawberry. I'm going to say this is a fruit. If you're a botany major, I'm sorry. I'm not following like the best categorizations of plants, but bear with me. You can modify this to suit your needs. All right. So this should be the types of information that we needed for our post request. So let's go ahead and send this post request and see if it succeeds. Yes, so we got a 201, it was successful. And it returned to us whatever it put in the database, which matches what we sent. That's great. All right. Can we verify it's now in the database? Let's do our GET request. And voila, it is here. And nothing else was changed. So that's great. So that is working. And I'm not going to test all of these, but let's just go ahead and test delete, see if we can delete a specific plant. So let's go ahead and delete kelp. All right. And the ID of kelp was 2. So we'll go ahead and delete that. We don't need a body and a delete. Send this. And 204. So we successfully deleted this from our database. Let's verify it. We can test the GET request on this specific number. This time it should be an error. See, 404, not found. And as you can see, it says, message, plant 2 does not exist, which is what we wrote over here. Cool, so we have deleted it from our database. Now you may be wondering, wait, but I see it right here. Well, whatever you write right here, this is how the database is going to be initialized when you do Python app.py. But as it is running, whatever its current state is going to be however you modified it. And then in the case of your own database, you're probably going to have a database that's either like hosted serverlessly by some other company, so it's going to have a state that isn't going to be wiped out once you turn off your server, or you might have a local storage or something like that. Cool. Great, so we just wrote a Flask API and demonstrated that it works using Postman. All right, so how are we actually going to like incorporate this stuff into React? I'm not going to spend too much time on this, but in your application, you're going to have a backend. You're going to put your servers, API stuff there, and your database there. Then you have your front end. I called it client just to remind you of this restaurant analogy. When you're making your application, your front end is going to be what the user is interacting with. So imagine this application, this nice plant gardening application, and you want to add a new plant to your garden. So I'm going to go ahead. Here's the code for this. It's going to be in the GitHub README. You can look at it, and I'll explain it in a bit. But I'm going to go ahead and change screen so you can see this web page. All right. So now you should be able to see this React app. Cool. And this is what the React thing rendered. So what I did was I created this form in JavaScript that takes a name, type, and age, which is exactly what we need to make a new plant. And we're going to go ahead and add a new plant to our database. So let me refresh this. Actually, wait a second. This is an old instance, so this should not work. Let's first turn on our front end. So let me actually go back. Whoops. All right. So over here inside of our front end or client folder, when you first create this, you'll do like npx create react app and the name of the folder. But after that, you can just go ahead and write npm start. Cool, and that should start our front end. Cool. So technically, this is also called a server, right? The definition of a server is very generic, so it's anything that kind of responds to requests and stuff. But this server is going to be calling the server that we wrote to handle our database. And that's what we normally mean when we talk about servers. Cool. So here's our application. As you can see, yes, these are the plants that we put into our database, our fake database. And now let's go ahead and add a new plant via our front end. So I'm going to call this plant bamboo. And I think bamboo counts as a tree. I'm not sure. Okay, let's add this. I'm pretty sure it does. Cool. How do we know this actually succeeded? One thing you can do, check your developer tools. All right. Normally inside your developer tools, you can see the console. If you wrote your JavaScript really nicely, you would have done console.logs. As you can see here, it says the plant was added successfully. Let me just refresh the page, see if it displays now inside of our database. Yes. Okay, it is here. Cool. So that is just an example of how to connect your database to your front end using an API server. In this case, we used Flask. All right. Oops. So one thing you want to do when you're writing stuff in React, because I'm assuming your front end is probably going to be in like JavaScript or like TypeScript, you want to use asynchronous functions whenever you're going to be calling your API. And the reason being is that sometimes when you ask your server to do something, or when you ask the waiter, for example, to bring you a certain dish, it's going to take some time for the food to get back to you. And in that case, you don't want that call in your code to block up the entire code and just make your time really, really slow. So you're going to make the function asynchronous. That means the lines below it are going to be executing regardless of whether this function has returned yet. It'll return when it gets its response. And then the typical format that we write our asynchronous functions as is to have a try catch block inside. Inside of our try block, we're going to do const response equals await fetch, and then the URL or the endpoint that you're making your HTTP request to. And then after this, there's a second parameter that you can pass in, which is going to be including the type of HTTP request that you're making. And await is something that you can is a keyword in JavaScript that you can only put inside of an asynchronous function. It's kind of like the opposite of asynchronous in that await will stop the code over here. So it's not going to go to the next line until fetch returns a promise. Fetch automatically returns a promise object, which is a specific JavaScript object. It's kind of complicated, but all you need to know basically is right here, fetch is going to be asking the server to get something. It's going to wait for the server to respond. Once it responds, it's going to assign the response into this variable. And we can get the body of the response using response.json. And then in the case that we made a request to the server, but for some reason our Wi-Fi was bad, and then our request got dropped, we have a catch block over here, which will catch that error and log it to our console, which we can see through developer tools, which is really nice. Let me actually show you the JavaScript code really quick just to show how I implemented it in this case. Cool. So this is a React app, right? So this is just the app.js. You might have like a different components, but inside you're gonna have your asynchronous function. So here's our asynchronous function. Here's our try, and our catch right over here. And here you can see we passed a little bit more than just the URL to our fetch request. That's because if you don't pass the second parameter, fetch is gonna interpret it as a GET request, but in this case we were adding a new plant to our database, so it was a POST request. So we just pass on this JSON specifying the method. Headers I don't think you actually need, and then the body. So when we're posting a new plant, we're obviously going to be wanting to include the information about it, and so we're going to use json.stringify, all right, in order to convert our information into the correct JSON object. All right, and then also one tip is when you write your try-catch block, inside of your try block, you probably also want to have something like if not response.ok or if response.status equals like 400, 404 or whatever. Throw a new error or like log to the console, because what if you made a request to your server and their server responded with a 400 or 500 status code? That's not going to be considered a network error, so it's not going to automatically cause this block to happen. So if you want to treat that as an error, go ahead and do it like this. Not response.ok means any response whose status code is not a 200. So that's basically how it works. Here is our function add plant. Here's another function fetch plants. As you can see, we didn't need the second parameter. This was used to display the plants when I refresh the page. And then we used, right, because this is React, we use useState and useEffect in order to store all of this. So useEffect meant that whenever we first loaded the page, we would fetch all the plants, and then we have our form over here, which takes in the name of the plant, the type of the plant, and the age of the plant. And then once we submit, then it's going to go ahead and call handle submit. And inside of handle submit, we called our function add plant, which was an asynchronous function. So after we called this, before perhaps it even successfully added the plant, it'll also go ahead and call this function, or use this hook in order to reset our plant data. Nice. So I'm going to post all of this in the same area as the README, so you can go ahead and look at it over there. But this is basically how you would integrate your backend and your front end. All right. So this was very simplified in terms of what you can actually do with Flask or with a server API in general. So maybe you might want to have auth tokens if you have like special endpoints that only super users can access. And obviously you're going to want to connect your server to an actual database, not just some fake database, in which case you might want to use Flask SQL Alchemy, or you might want to use Flask Mongo Engine or some other library. Python has like a bazillion libraries that can handle all of those for you. Just search up for your specific database. And then once you do that, you will notice that you're going to have to do a lot of environmental configuration. You can simplify that and make it cleaner by putting it into a .flask environment file. That'll save you a few lines of code. And if you're really just itching to make your API super beautifully defined, you can use Swagger UI to just make this really nice looking API interface. But honestly, you probably don't need to do that. And for all the Django lovers, nothing's stopping you from doing more work. So great. That was all I had for you guys today. Happy hacking, and I hope that you found this tutorial useful and informative.